Welcome to the first video in a series of 4 videos that will walk you through the creation of your own tiny little GPT model. Before a GPT model can predict words, it has to forget that words exist. It only sees numbers. In this video, we'll cover 3 things. Why models need to convert text into numbers in the first place, exactly how that conversion happens step by step, using a process called tokenization, and what that stream of numbers looks like just before it enters the model for training. Welcome to Scovia Labs, where we turn AI concepts into everyday intuition. Let's start with a problem that is easy to overlook. You and I read sentences. We see words, spaces, punctuation, and a large language model sees none of that. It only accepts numbers as input. So the first question is, how do you turn a sentence from an AI textbook into a list of integers that the model can actually learn from? That is what tokenization solves. Tokenization is the step that sits between raw text and the model input. It converts text into discrete units called tokens, and then it maps each token into unique integer IDs. There are 2 obvious brute force type of approaches to tokenization, and both of them break. The first is to treat every word as a token. That sounds intuitive, but it creates a vocabulary size problem. English alone has hundreds of thousands of words, like different names, typos, domain-specific terms, and new coinages, and the list never ends. The model would need an enormous lookup table, and it would still fail on any word that it hasn't seen during training. The second approach is to go all the way down to individual characters. That solves the unknown word problem. The model can always spell anything out, but it creates a different pain. A single sentence becomes dozens of tiny pieces. Longer text becomes hundreds, and the language model's context window, like how much it can process at once, fills up fast when every letter is its own token. So character-level tokenization means the model can only see a short stretch of the text at a time. It can read, but it reads very slowly. What we need is something in between. Not whole words that expose all the vocabulary, not bare characters that stretch the sequence, but reusable chunks that appear again and again across text. That sweet spot is subword tokenization. And the method used to learn those subword chunks, the one that's behind GPT and most modern languages, is called Byte Pair Encoding, or BPE. If you want to understand byte pair encoding in depth, we have a full video on it. Link is in the description. The short version is that byte pair encoding starts with individual characters and repeatedly merges the most frequently occurring adjacent pairs into single new tokens. Repeat that enough times, and you end up with a vocabulary of reusable subword pieces that compress text efficiently. A link to the website that shows this process of byte pair encoding is provided in the description. So once byte pair encoding is done, what we have is a vocabulary of subwords that the model understands. It might look something like this. Now let's trace exactly what happens to a line of text before it enters the model. Take this sentence, for example. The tokenizer scans the text and breaks it into the subword pieces that exist in its vocabulary. Artificial might stay whole because it might have appeared enough times in the textbook. And similarly, technologies might be split if those pieces are not as frequent together but frequent individually. Is and A are short and common enough to each be their own token. The exact splits depends entirely on what patterns were frequent in the training data. The tokenizer didn't read a grammar book. It just learned what pieces show up together a lot. Once the text is split into tokens, each token gets mapped into a unique integer from the vocabulary. Like artificial might become an ID, like 668, intelligence might become 664, and so on. What comes out of this process is not a list of strings, it's a list of integers, something like this. That is what the model actually trains on. There's one more detail worth naming. There are some special tokens. Most tokenizers reserve a few IDs for structural markers, like BOS, token, which is short for beginning of sequence, which signals where a document starts, and an EOS token, which signals where it ends. These markers let the model know where one piece of text stops and another begins, especially when many documents are packed together into a single long stream of training. And here's how it plays out in practice. When you train a model on a textbook or any corpus, you don't feed it one chapter at a time. You take all the text, tokenize it, and then concatenate the IDs into one very long stream of integers. For our TinyGPT, that stream might look like this. The ones are BOS tokens, the twos are EOS tokens, and everything in between is the encoded text. From that stream, the model will learn by reading windows of tokens. A chunk here, a chunk there, always trying to predict the next one. But that's the job of the second video. So right now, the key idea is that the model never sees letters, spaces, or words. It sees a river of integers, and tokenization is the step that turns an AI textbook into that. One misconception that's worth naming directly is that tokenization is understanding. The tokenizer does not know what intelligence means. It does not know that AI is a field of study or that technologies is a plural noun. It is a compression step, not a understanding step. It converts text into a compact, consistent numerical format that the model architecture can consume. The meaning, if the model develops any from this, comes later through training. The tokenizer just builds the alphabet that the model is going to learn from. So the takeaway is that GPT never reads the text directly. It reads a stream of integer IDs where each ID represents a subword token learned from the training data. Tokenization sits between raw text and the model, converting one into the other. Not using words, not using bare characters, but using reusable subwords that balance vocabulary size against sequence length. That balance is the whole game. A smarter tokenizer means a more efficient model because the model can fit more meaning into the same context window. I hope watching text turn into numbers made that step feel a little less invisible. A Colab notebook that does this tokenization is shared in the description. In the next video, we'll take that long stream of IDs and show how TinyGPT carves it into batches, the actual input-output pairs that the model trains on. Please subscribe to Scovia Labs for more visual walkthroughs of how AI actually works. And as always, stay curious.